Hello folks, I'm back after a long time. So today I'll be dealing with some graphs related to kinematics. I'm specially proving an equation of kinematics from graph, and that will be with the help of another equation. So the equation that I am dealing with is first. Let us realize. We have 4 equations of motion. So the first one is A equal to V minus U by T, which becomes V equal to U plus AT. So it becomes V is equal to U plus AT. Then the next one is it is about S is equal to U plus V by 2 into T. This is the equation for the displacement. And this term is the average velocity, and then it is the time. The next one is time, and the average velocity. The equation for this average velocity holds only if the velocity increases or decreases uniformly. That means the acceleration is constant. Otherwise, that U plus V by 2 does not apply. Now, the third equation is S equal to UT plus 1 by 2 AT squared, and the fourth one is V square equal to U square plus 2AS. And if we are interested, we can add one more. It is S is equal to VT minus 1 by 2 AT squared. So these are the 5 equations. Now what we now do is from this equation, I will prove that the displacement is also given by the area of the VT graph, the area of the velocity time graph till the given time. And from that, we will be again proving from that graph we will be proving this equation. So this will be converted to graph, and from that graph I will be proving this equation. So for that, let's draw a graph first. So the graph will be somewhat like this. This is the y-axis, this is the x-axis, this is time here, time O, it is velocity here, velocity. So let us assume that the body is traveling with uniform acceleration. That's why the velocity increases uniformly from its initial value till the given time. So the initial value is this, which is U. It increases uniformly like this till the given time, this is T. So this is the time T, from 0 time to T time here. So the velocity will now reach here. So from here to here, this thing is U, this is U, and this will be, so here this velocity will be V. So you have U is the initial velocity and V is the final velocity, and this thing will be time T. So from this graph, what we have to prove that the displacement S is equal to the area of this graph, area under this graph, let us say. So for that requires, let me draw this thing here, this thing perpendicular to this thing, perpendicular, and give them some names. So this is O, this is A, this is B, C, and I'll be using E. And the students often ask me why I'm not using D. So D goes for distance, so that I don't want to mix up symbols here. So if this is U, then this thing also should be equal to U, and this thing should be equal to V minus U, which is evident from the graph. So I'm only doing those things which are evident from the graphs. So now, let me find the value of S. So from this graph, I want to find the value of S. So S is equal to, from this equation, S is equal to UT plus 1 by 2 AT squared. Now what I do is, I will modify this thing slightly. It will be equal to UT plus 1 by 2 AT first and then T. So for T square, I have used T and T, and I have separated them like this. Now what happens here is, we know that so V equal to U plus AT which gives us this AT is equal to V minus U. V minus U. So I will substitute this thing over here and it will give me, so therefore S is equal to UT plus 1 by 2, then V minus U, then T. So like this. Now what I do is, let me use the values from the graph here. So here U is equal to, from the graph we have U is equal to either BO or this thing EA. Either BO or let us say AE. Let me use alphabetical order. So it will be either BO or is equal to AE. Similarly, the time T will be equal to either AO or let us say this is BE. Either AO or BE time. Then I have got your V minus U. So V minus U will be equal to, from here it will be equal to simply CE. This is C into E. So now C S will be equal to, so instead of U I will use here I will use for U I will use BO. Then instead of time I will use AO. So BOU and AO is the time T. Then plus 1 by 2. V minus U is CE, of course, CE here. It is CE, and then T is, the time is equal to, I'll use this time BE here. I'm not using AO because I have some selfish motives of mine, let me say. So this is B into E. Now, let us see, what is BO into AO in this diagram? What is BO into AO in this diagram? So it will be equal to, if I do BO into AO, it will be equal to the area of this region. BO into AO will be equal to area of this region. Similarly, if I do half CE into BE, so half CE into BE, it will be equal to the area of this triangle. It will be equal to the area of this triangle. So let me use another color here, So it will be equal to area of this triangle. So now I can write it here. So what I have here is, this thing is equal to area of rectangle. So from here I'll write, so AEBO, let me say AEBO plus, this thing is area of the triangle, so it is area of triangle BCE. Now the whole thing becomes the area of trapezium. Area of trapezium, it will be ACBO. So it will be equal to whole area. This will be equal to the area of the whole trapezium here. I can write it like this. So it is the whole trapezium like this. So this gives us the displacement suffered by the body during this time. Now, if I have the graph like this, simply it is a time here, this is a velocity here, graph like this, and till this time our equation will be equal to somewhat like this. S will be equal to this thing. If I have a graph like this, this is time, this is velocity, and like this, the area will be somewhat like this. So whatever may be, the displacement is given by the area covered by this graph till the stipulated time, till the given time or the stipulated time. Now, so as you know, it is equal to the area of trapezium ACBO. Now from this, I am going to derive this equation. From this particular aspect, I'll be again deriving this thing. So let's try. So this will be the starting formula for us to derive this thing. So let's do it. So let me write it here in the very beginning. So this S is equal to area of trapezium ACBO equal to it is 1 by 2. So the area of trapezium is equal to 1 by 2 into sum of the parallel sides into the perpendicular. So that's why I'll do like this. the parallel sides are AO, so it is or AO plus it will be it is BO, parallel sides is BO plus it is AC and it is multiplied by into AO. So I'll change it slightly. So 1 by 2 BO plus AC, and instead of AO I'll use BE. So into it is BE into BE. So this will give us, now I have to modify things slightly. So what I'll do now is it's equal to 1 by 2 BO plus AC into, so BE, it is a B here, so BE by, I will multiply this whole thing by some quantity of interest to me. So I'll be doing something, I'll divide this thing by something which is of interest to me. So I'll divide it by CE into CE. So multiplying the numerator and denominator by CE. So it has come from heat and trial. So I actually don't know what is this, but with heat and trial, I later on come to know, which is the same with you as well. So what I'll do here is, so it is BE by CE into CE equal to 1 by 2. What is BO? BO is equal to U. It is U plus. What is AC? AC is equal to, it is V. Then into, what is BE by CE? What is BE by CE? It is, let me say 1 by CE by BE. So I have shifted this BE below this CE and got this into, what is CE? CE is equal to this V minus U. So it will be equal to V minus U. So this is, I'll do it as a 1 by 2 V plus U like this into 1 by, what is CE by BE? So CE by BE is equal to the slope of this line. And that slope is equal to the magnitude of acceleration. See, slope of the VT graph is equal to acceleration. So that's why I'll do like this. It is 1 by A, then V minus U. So now I can multiply several things here, So this will give me equal to V plus U, V minus U. It becomes V square minus U squared. 2A, it becomes 2A. So this is S equal to V square minus U square whole by twice A. And that becomes, or I'll have 2AS equal to V square minus U square, or I can say V square equal to U square plus twice AS. So this is the fourth equation as obtained from the graph, and the graph has been obtained from the third equation. So equations of motions are very much related to each other, and graph is also a very good way to study motion, to study the nature of motion. It helps us in determining several quantities like that.